Acceleration as a function of time. Acceleration is a vector quantity which has a magnitude and direction. Okay, the definition is the rate of change of velocity with time. So later on, you will learn that when you are given a velocity function and when the question asks you to find acceleration, acceleration is actually differentiation of velocity function with respect to time. So A is dv dt. That means the rate of change of velocity with time. If the movement of a particle to the right is positive, then when the velocity of the particle is increasing with time, A is greater than 0. That means when you drive and you speed up means velocity is increasing, means you are accelerating. So that's why A is greater than 0. When the velocity of the particle is decreasing with time, means let's say when you drive, you slow down. Slow down means you are decelerating, means A is less than 0. Okay, next one. Let's say you are given a velocity equation, and then if the question asks you to find the maximum or minimum velocity, the concept is same as the differentiation chapter. Whenever we see the word maximum or minimum, we will do differentiation and let it be 0. So let's say you have a velocity function, then we will do differentiation, means we will do dv dt and let it be 0. So dv dt means A, okay? That means A is equals to 0. That means velocity is maximum or minimum, means A is equals to 0. Instantaneous acceleration is an acceleration at a certain time. That means if the question asks you to find the instantaneous acceleration when t equals to 5, means you just have to substitute t equals to 5 into the acceleration function. It can be obtained by determining the gradient of tangent of velocity time graph. We will see this later. Okay, uniform acceleration means the rate of change of velocity with time of an object is the same at any time. Non-uniform acceleration means the rate of change of velocity with time is different at any time. The gradient of tangent at one point of the velocity time graph can be used to determine the acceleration. Let's check one example. A woman swims along a straight path. Her velocity v meter per second at t seconds from the initial point O is given by v equals to 4t minus t squared. Let's say we want to draw a velocity time graph from t equals to 0 until t equals to 6. So you can draw a table like this, and we substitute the value of t into the velocity function. So when t equals to 0, we have answer v equals to 0. When t equals to 1, v equals to 3. Okay, so since we are going to use the velocity time graph to determine the acceleration, we also can identify the acceleration equation now. So when you are given a velocity function and when you want to find acceleration, you can do differentiation. So 4t minus t squared, when we do dv dt, we have answer 4 minus 2t. So same thing, you just have to substitute the value of t inside to get the value of acceleration. So when t equals to 0, we have a equals to 4. When t equals to 1, we have answer a equals to 2, and so on. Based on the value here, we can draw velocity time graph. Okay, so we have a look at these two rows. When t equals to 0, v equals to 0. So we have a point here, 2, 4. So this is the maximum point of the graph. 4, 0 is the x-intercept, 6, negative 12. Okay, so this is the velocity time graph. So based on the graph, we check when t is in between 0 to 2. Okay, we check the value of v from 0 to 3. Means we notice that velocity is increasing. Okay, then let's say you have a point here, and when you want to draw a tangent line, we notice that the tangent line slants to the right. That means dv dt is greater than 0. dv dt is a. That means a is greater than 0. Okay, that means for t in between 0 to 2, velocity increasing, dv dt greater than 0, a greater than 0, that means the swimmer is accelerating. Okay, next one. When t equals to 2, we check the value here, 2, 4. This is the maximum point of the graph. Okay, so velocity is maximum. And for this point, when you want to draw a tangent line, you notice that this tangent line is a horizontal line. That means dv dt is equals to 0. dv dt means a, so which means a is equals to 0. Okay, so that means you have to remember when you have 0 acceleration, it doesn't mean that velocity is 0. In fact, it means velocity is either maximum or minimum. So in this case here, velocity is maximum and you have a equals to 0. Okay, next one. When t is greater than 2, let's check the reading here. Okay, we have our velocity value, 3, 0, -5, -12. Means we notice that the velocity value is decreasing. Okay, so velocity is decreasing for this part. And when you have a point here and when you want to draw the tangent line, we notice that the tangent line slants to the left. That means dv dt is less than 0. dv dt is a, that means a is less than 0. Okay, so when t is greater than 2, we have dv dt less than 0, a less than 0. That means the swimmer is slowing down or decelerating. Example 11. A particle moves along a straight line and passes through a fixed point O. At t seconds after passing through O, its acceleration a meter per second square is given by a equals to 12 minus 4t. Calculate the instantaneous acceleration of the particle when t equals to 7. So when they ask you to find instantaneous acceleration when t equals to 7, means the answer of acceleration when t equals to 7. So we just have to substitute t equals to 7 into the acceleration function. Okay, so after we sub, we have answer a equals to -16 meter per second square. Example 12. The acceleration of a particle is given by a equals to 8 minus 4t. Find the instantaneous acceleration of the particle when t equals to 4. So we just have to substitute t equals to 4 into the acceleration function. Then we have a equals to -8 meter per second square. B, calculate the time in seconds when the velocity of the particle is maximum. When the velocity is maximum, means dv dt equals to 0. And dv dt is actually a. That means a equals to 0. And the acceleration function is given by the question. So we just need to substitute 8 minus 4t equals to 0. Then we have answer t equals to 2. Okay, next one, C. Determine the range of time in seconds when the velocity of the particle is increasing. Velocity is increasing means it speeds up, means accelerate. So that means a is greater than 0. So we have 8 minus 4t greater than 0. Okay, this is linear inequality. So to play safe, you can do step by step. This is -4t. I just bring over to the other side. I didn't change the symbols here. Okay, and then 4, I bring to the other side to divide. So we have answer 2. 2 is greater than t. That means t is less than 2. Okay, so whenever you find the answer like t less than 2, means t is less than a number, please do one more step. Because t cannot take negative value, so your final answer should be t is in between 0 to 2, and t can be 0. So here you have to put equal sign. Example 13. The acceleration of a particle is given by a equals to 4 minus 2t. Find the initial acceleration of the particle. So whenever we see the word initial, means t equals to 0. So they are asking you to find the acceleration in the beginning of the experiment. So we just need to substitute t equals to 0 into the acceleration function. then we will have answer A equals to 4 meter per second squared. B, determine the range of time in seconds when the velocity of the particle is decreasing. Velocity is decreasing means the particle decelerate, means A is less than 0. Okay, so 4 minus 2t is less than 0. The negative 2t bring over to become positive 2t. Then 2 bring over to divide. We have 2 less than t. That means t is greater than 2. So this is the final answer. Okay, not like just now. Just now, for example 12, the answer is t is less than 2. Okay, and t cannot take negative answer. That's why you have to take one more. You have to write one more line. T is in between 0 to 2. Okay, but for our answer here, t is greater than 2 means answer is 3, 4, 5, 6, 7. Answer won't be negative. That's why it is correct. Just remain.